And here you will have the answers revealed and explained to you for the questions that will likely show up on your test that you are getting ready to take dealing with quadratic equations. The first 9 questions are dealing with vocabulary, right? And they will show up either in a multiple choice or true, false, or even matching type situation on the test. So you do need to know your vocabulary and what they signify in terms of this chapter. For number 1, the standard form of a quadratic equation is written as y equals ax squared plus bx plus c. And you do need to have the y equals part in front of that. Number 2, a quadratic equation is a polynomial equation of degree 2. Quadratic means power of 2. Number 3, a solution to a quadratic equation can also be called a zero or root. Okay? And yes, it can also be called x-intercepts. Right? So if you had that down, that would still be acceptable. For number 4, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over top of 2a. And that is used to find the solutions to a quadratic equation. Number 5, a quadratic equation has a U-shaped graph that is called a parabola. For number 6, the lowest or highest point on the graph of a quadratic function is called the vertex. Okay. Number 7, the blank is the line that passes through the vertex and divides the parabola into 2 symmetric parts. That would be your axis of symmetry. Okay. Number 8, to find the x-coordinate of the vertex, you will use the formula x equals negative b divided by 2a. Right? That question will not show up on the test, so do not stress over that one. Right? You do not need to know that formula. We know of how to get the axis of symmetry equation from using the vertex. For number 9, a parabola opens up when the a value of a quadratic function is positive, and down if the a value of a quadratic function is negative. Okay. For numbers 10 through 12, you are matching the correct statement on the left with the number of solutions on the right. Right? So in number 10, given that x squared equals a certain number and the d value is greater than 0, that would mean that it is positive. Right? Then you will have 2 real solutions, which is letter C, and that's why you have to have the plus or minus sign. In number 11, if you have the value of d where it is less than 0, that would be negative number, right? Then when you go to square root it, you will have no real solution, so that is letter A. And then if d is 0, when you go to square root it, then you only get one solution, and that is 0, right? So you do have to tell me and be able to show me how many answers something will have based on when you square root those problems. Right, for 13 through 16, you are simply evaluating. Remember that whatever signs are outside the radical sign must appear in your final answer. So the square root of 81 is just 9. Negative square root of 49 makes negative 7. Okay. For number 15, plus or minus has to be in your answer because it's on the outside. The square root of 0.16, right, is 0.4. Okay. For number 16, the square root of negative 1, where the negative sign is inside, you cannot do, so that's when we write no real solutions. Okay. For number 17 through 23, this is your square root and cube root section where you have to simplify, right, based on the numbers that are there. This is where you use your list of perfect squares and perfect cubes to get your answer. There should be absolutely no decimals in this section because the trick to these is simplifying. So for 17 through 20, you have square roots, and 23 also has a square root, and then 21 and 22 are perfect cube roots, right? So for 17 through 23, right, you're going to use the perfect square list, right, which remember is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Okay, so we're using all of those numbers to help us with number 17 through 23. All right, for number 17, 147 doesn't look like it's got anybody that can divide in it, but if you take these numbers and you try it out, there is a perfect square in it, and it's actually 49. So when you split this one apart, you're going to split it into the square root of 49, and 49 times 3 is what makes 147, so that's the square root of 3. The square root of 49 is the whole number 7. Radical 3 stays radical 3. So there's your answer to number 17. Number 18 is the number square root of 24. The largest perfect square in 24 is 4. There are other numbers that make 24, but only the 4 is in the perfect square list. So it's the square root of 4 times the square root of 6. The square root of 4 is the whole number 2. Square root of 6 stays 6. Right, for number 19, you have a fraction. It cannot be reduced, so the next thing you need to do is split it apart. So this is the square root of 13 over the square root of 9, and then look for your perfect squares. The square root of 9 is a perfect square, and that makes the whole number 3. The square root of 13 does not have any perfect squares in it, so it stays radical 13. Right, there's nothing to reduce, so you're done. When you go to number 20, the 6 on the bottom is already a whole number, so we're going to leave that as is. But the 63 up top can break down into a perfect square and a non-perfect square. 63 is made by 9 times 7, so that'd be the square root of 9 times the square root of 7. Right? The square root of 9 is the whole number 3, so I have 3 radical 7 over 6. And remember, the last thing you want to check to do is to see if you can reduce your outside numbers. 3 and 6 can reduce to 1 and 2. So your final answer would be radical 7 divided by 2, or you can put the 1 in front and that's acceptable as well. Okay. I'm going to skip over 21 and 22 simply because those use cube roots and that's a whole different list. But for number 23, that's also using perfect squares, especially for the number 243. The only difference between 23 and the rest of them is that there are letters involved, right? And you do have to know how to break apart the variables, right? So but the first thing we want to do is break apart this 243. It's got to have one of our perfect squares in our list, and we need to find the biggest one possible. So if you start towards the back and work your way towards the front, you'll find that 243 can be made by the square root of 81 and the square root of 3. Now when you go to write your final answer, right, you are going to have a radical sign, but you want to leave space on the outside and on the inside to accommodate the letters as well. So the square root of 81 is the whole number 9, but I'm going to leave some space between because I know there's going to be some letters sticking between the 9 and the radical sign. The 3 stays under the radical sign, but I know there's going to be some letters possibly under there too. Remember, if you have an odd amount of exponent for a letter, you're going to have one that stays under the radical and then some that come out. If you divide each number by 2, you'll figure out how many come out and how many stay in. So if I take the exponent 3 and divide by 2, I get 1.5, which means 1x comes out, and every time you have a 0.5, that means 1 stays in. So it looks like this, right? If you take the y's, 5 divided by 2 is 2.5. That means 2 y's come out, and because of that 0.5, 1 always stays in. So there's your final answer with variables. You will have to do at least a couple problems dealing with the variables and numbers. All right, now for 21 and 22, right, those are dealing with perfect cubes, which is a whole different list, right? And your perfect cube list, we don't have to write as long because we don't typically go as far, right? It does start with 1, 2 cubed would be 8, 3 cubed would be 27, 4 cubed is 64, 5 cubed is 125, and you can actually stop there. If you need to go any higher than that, you can use your calculator to help you out. Right, so if I look in this list for number 21, the cube root of 64, 64 is already in my list, which means it's a perfect cube on its own. So the cube root of 64 is 4. Right, there is nothing left over because it's its own perfect cube. Right, so you can use the calculator button to help show you that too. Now 22 has the number 24. 24 is not in this list, but the cube root of 24 can divide by a number that is in the list, and it can divide by 8. So we have the cube root of 8 times the cube root of 3. Make sure you have that little 3 outside your radical sign because that's what tells you it's cube root. So the cube root of 8 is the whole number 2, and then the cube root of 3 stays cube root of 3. Right, so you will have a couple of cube roots you will have to deal with as well, right, but not near as many. So it's the same process, just a different checklist that you're using or a different list of numbers that you're using to help you out. All right, for 24 to 29, this is where you're solving your quadratic equations by using square roots. No factoring and no anything else. No quadratic formula, just straight up square roots. Right, and this is where you have to remember to put your plus or minus sign if you need it. So for number 24, x squared is already by itself, so I can jump in and square root both sides. Because 64 is positive, I'm going to need a plus or minus sign in my answer, so I'm going to go ahead and put it already. The square root of x squared leaves me x, the square root of 64 leaves me plus or minus 8. Right, for number 25, I want to get x squared by itself, so I divide by -3 on both sides. That leaves me x squared equals -16. I square root both sides, and then I see that I can't square root a negative number. So that tells me my answer has to be no real solutions. Make sure you have the word real in your answer. For number 26, I need to divide by 5, and I get x squared equals 40. 40 is a positive number, so when I go to square root both sides, my answer is going to say x equals plus or minus. But if you look at the square root of 40, the square root of 40 is not a perfect square. So it tells us in our directions that if it's not, then we have to write the answer in radical form. So there's two possible ways to do this, and I will accept both. Right? Just leaving it radical 40 with a plus or minus sign in it is fine. I will accept that. If you wanted to simplify that because you see that there's a perfect square in there, you could also write it as plus or minus 2 radical 10. Because if you break up 40 into square root of 4 and square root of 10, you get simplified to 2 radical 10. So either one of those is acceptable as long as you have the plus or minus sign in front of it and that the radical sign is still in your problem. Right, for number 27, we want to add 11 to both sides. So now you've got 5x squared equals 45. Divide by 5 on both sides, and you've got x squared equals 9. That's a positive 9, so when I go to square root both sides, I'm going to put my plus or minus in my answer. Square root of 9 is 3, so the answer is plus or minus 3. For number 28, I'm going to subtract 19 from both sides, so now I've got 3x squared equals 0. I'm going to divide by 3, and I've got x squared equals 0. When I go to square root both sides, the square root of 0 is just 0. Okay. And then for number 29, I need to add 117 to both sides. So that leaves me with 9x squared equals 117. Divide by 9. That leaves me x squared equals 13. Okay. I'm going to square root both sides. I know that my 13 is positive, so I'm going to have a plus or minus in my answer. Square root of 13 is not an integer, so I need to leave it in radical form. Okay, I can't simplify it, so the only way to write this answer is plus or minus radical 13. Okay, so you will have a pretty lengthy section that asks you to solve quadratic equations using square roots. All right, now the back side has you dealing with the graphing aspect and the quadratic formula, which are the newest pieces and the last pieces that we covered in class. Right? For number 30, you will have to take one equation and you will have to demonstrate that you understand all pieces that are being asked for. You will be asked for the vertex, the axis of symmetry, the solutions, which are also known as the roots, the zeros, or the x-intercepts. Those are all the same. They all go to the same word. Okay. Domain will be asked, range will be asked. You will be asked to provide a table of values and a picture of the equation. Right. So for this problem, x squared plus 6x plus 8 equals 0, you have several options. Right. You can go straight to the table or you can identify certain pieces already. Right. I'm going to go straight to the table. Right, and find out my section that's odd. Right, so when I type in the equation x squared plus 6x plus 8 in my y equals spot and I go to second table in your calculator, you're going to see the table pop up. And remember, we're looking for the oddball in the y column, the number that is different from all the other numbers that aren't being repeated. Right, and you'll find it at -3, -1. Okay, that's your vertex. So when I go to write my vertex, it's the ordered pair, -3, -1. You must use an ordered pair with parentheses on the outside. Right? That means I want to have -4 and -5 above it, and -2 and -1 below it. Right? And then if I fill in my spots from my table, that'd be a 3 and a 0 and a 0 and a 3. Right? I'm ready to go make my picture next, and then I'll fill in the rest after that. So you go left 5 and up 3. There's the first point. -4, 0 would be right here. -3, -1 would be right here. -2, 0, and then -1, +3. Right? And remember that your graphs are U-shaped graphs, so as you draw them, make sure that they look very similar to a U and not a pointy V. Right, so there's our graph. Right, now from that information, the graph and the table, we can fill in all the rest. Your axis of symmetry, remember, comes from the x value of your vertex, and you must always write x equals. So I can either use my picture and figure it out, or I can use my vertex. The x value is -3, so my axis of symmetry is x equals -3. Right, now your solutions are your x-intercepts or your roots or your zeros. You can find them in the picture or you can find them in the table. It's wherever the y value is 0, and there are 2 of them in this problem. And we usually write them in braces. That would be -4 and -2. If you want to write both ordered pairs, that is certainly acceptable. Right, just know that it's all asking the same thing. The domain for every parabola that is a function is always going to be all real numbers. Okay, and I will accept the interval notation for that, which would be negative infinity to positive infinity, if that's what you prefer. Right, so do have one or the other. You do not need to give me both, though. For the range is the y values, and it deals with as low or as high as this graph will go. Right, and it always deals with the y value from the vertex. So if you go back and you look at your vertex, the vertex has a -1 in the y spot, which means your range has to involve -1, because that's actually the lowest point that this graph can go to. So if you're going to write it in regular formation, it would be y is greater or equal to -1, which means it's -1 or higher. If you're going to write it in interval notation, it would be bracket -1 to positive infinity and close your parentheses. So pick a way to write it and stick with it, but make sure the way you write it is correct. All right, and then number 31 is dealing with the most newest thing, and that would be your quadratic formula. You do get that quadratic formula on the formula sheet, but many of you have probably memorized it by now just because of the way we interact with it in class, or the fact that it's just a weird looking formula all the way around, right? So your formula for a quadratic formula is -b plus or minus the square root of b squared minus 4ac divided by 2a. You also had this formula in one of the fill-in-the-blank questions on the front side of this paper, so you could have looked back and found it there. Right? Before you start plugging things in, you have to pick out your a, b, and c from your equation, and they're literally in order, and they're the numbers in front of your variables. So a, which is your leading coefficient, is -2. B is 6, and C is 9. If you write those out, it helps you very quickly and easily to insert them into the formula and see what's going on. All right, so for B, if it's a positive number and you stick it behind a negative number, it's going to be -6 plus or minus square root, and then b squared would be 6 squared minus 4 times a, which is -2, times c, which is +9, all over top of 2 times a, which is -2. Right? And now you want to clean this up. I caution you with trying to type in every little piece of this into the calculator, because it is a lot, and if you slip up in one little detail, right, the calculator will not give you the right answer. My advice to you is to do order of operations and get at least the radical part down to one number, and then use the calculator for everything else. Right? So that's what I'm going to show you through here. Right, so we're going to leave -6 alone on the outside, keep the plus or minus sign, and then under the radical sign, I'm going to clean it up a little bit. Exponents have to go first, so 6 squared is 36, and then I have a -4 and a -2. That creates a positive. 4 times 2 is 8, 8 times 9 is 72. All right, so there's my new numbers underneath the radical. And then on the bottom, I can go ahead and clean up the bottom. 2 times -2 is going to be -4. Right, now before I go any further with the calculator, I want to clean up that radical one more time, right, and get it down to one number underneath, because it's a lot easier to use the calculator with one number instead of a whole math problem. Okay, so you have -6 plus or minus the square root of 36 plus 72 is 108. Okay, and that is divided by -4. Okay, you do not need to worry about simplifying the square root of 108, because you're going to go straight to the calculator and evaluate this problem. Right? This looks like the problems that we did at the very beginning of the chapter, where you learned how to type in the entire thing in the calculator and come up with 2 solutions that come from this. And your answers will be decimals, simply because that's why we use the quadratic formula. It's because the problem could not be factored, right? And it couldn't be used with square roots, so we had to have another way to get the answers. And if you were to graph that equation, you would see in the graph that it doesn't cross through perfectly at a whole number. So that's when this formula becomes very useful and accurate. Right? So after you type in the first one, -6 plus radical 108 divided by -4, right, you should end up with a solution of -1.10. Remember, we round to the hundreds place. And then when you type in -6 minus radical 108 divided by -4, you should end up with 4.10. Okay, and then close your braces. Those are the 2 solutions that come from that equation, but the only way to get them is through using the quadratic formula. You will have to do the quadratic formula for one problem on your test. Right? So hopefully we practiced enough with it in class, and that you feel comfortable enough with it that it will not be a problem for you. Right? So use this to study off of and prepare for the upcoming tests, right? And then we'll see how you guys do.